over IZZ, right? QZ divided thickness. So from here, we have to find IZZ. So we know that once we are locating IZZ, so we know that this direction is our width, and perpendicular direction, this is the depth. Right, so we're going to start. So we know that this will be equal to twice IAB. Why twice AB? Because IAB, so for this sense, I'm going to write a footnote now here, note that IAB is equal to IFG, right? They have the same width, they have the same depth, they have the same position relative to the centroid. Okay, so the green line that I've drawn is a centroid. Okay, so that's why 2, and then plus by twice IBD, and then y twice again because IBD is equal to IEF, and then plus by once of IDE. Okay, so that is why sorry people, I'm still sleeping. Okay, so IZZ is equal to, yeah, Eugene, what are you doing? Twice. Okay, here you go. Sincerely apologize. Okay, right, so it's very obvious, right? So from here we're going to find, so I put the note down here. Okay, so IZZ is got twice IAB. So AB, the width is T, the depth is A cubed over 12, plus by the area, which is T times A, and the offset distance of the individual section. So the individual section is over here, right? So we know the distance from here to here is A over 2, right? And then you add another A, so it's equal to 3 over 2A squared. Then plus by twice again IBD. So the width is 2A, the depth is T cubed over 12, right? Then plus by 2AT, the area multiplied by the distance from the centroid to the individual section centroid. Okay, and then lastly plus by the width is T, then you have 2A cubed over 12. You don't need to plus because the individual centroid for member DE is the same as the global centroid. So that's why you have nothing to mind. If you're going to write this down, so plus by T multiplied by 2A multiplied by 0 squared. Okay, we have to write it down. Now, I need you all to pay attention down here with me. Okay, I need you all to pay attention down here. So what we have down here is 2 TA cubed over 12 plus by so this will be equal to I'm having a brain not moving. So this is equal to 9 over 4, right? TA, so this one divided by A squared, right? Is it A squared? No. What am I doing? I do apologize. I wrote this wrongly. It's 3A2 squared. Okay, my bad. So 9 over 4 TA cubed. Okay, then plus by twice, okay, 2a t cubed over 12 plus by 2t a cube. I know I'm not standardizing down here. Then plus by t a cube divided by 6. Okay. Now, what I want you to take note is you can drop this term. So I'm going to write down here, you can drop this term. Okay, you can assume this term equal to 0 because t cube is very small. Okay, so anything that's t cube, drop it. Okay, so that is the only term that's t cube. The rest are not t cube at all. So from here, we have 1 over 12 plus by 1 over 12 plus by 9 over 4 times 2. Then you have 14 over 3 ta cube plus by 4 ta cube plus by is it for plus by ta cube over 6. So 14 over 3 plus 4 plus by 1 over 6. You have 53. I think I missed up something, sorry. So 1 over 12 plus by 9 over 4 times 2. So 14 over 3 is correct. Okay, then I get sorry people, careless mistake. Today I'm not right. So it's 8 ta cube over 12. So this is 2 ta cube over 3. Sincerely apologize. So it's good. 28 over 3 ta cube. Okay. So again, what is more very critical is when you have t cube, you drop it, okay, because it's very small and insignificant. Okay. So the next thing that we do is is the way that we have divide the member. Okay, so we have divided to member A, B, B, D, D, E, E, F, and F, G. So we're going to look at section A, B. Okay, we're going to look at section A, B. Okay, so let me copy this. Anyone, any questions so far? Anyone, please? Anyone? No? Okay. So we're going to look at, copy this. Okay, so we're going to look at section AB. Okay, we're just going to look at section AB. So what we're trying to do now, we are trying to find the shear flow. Okay, we're going to trying to find the shear flow or shear flow for each section. So we know that the force coming down is in Vy. So we're going to construct the shear flow. So anything that is vertical or that is not passing the centroid, okay, has an F. Okay, an F. Let me classify what I'm trying to do down here. So the first line that we're going to construct over here, so this is our V. Okay, this is our V. And that's the only V that you got because it passes the centroid. Passed the centroid. If it passes the centroid, you call it V. The rest, okay, the rest. So over here, we have coming here F1. Okay, then over here F2. So it has to follow the V direction. Then it's going down. Then over here is F3. And coming down here is F4. Like what I taught you before, right? It depends on the vertical web, what direction is flowing relative to the Vy. Okay, so this direction over here and this direction over here are the same, as you can see, right? So we're going to find, so from here, we're going to find what is F1, F1, F2, F3, and we can find what is our what? F4. Okay, so let's find F1. So F1 is acting on section AB. Okay, F1 is acting on section. So I'm going to do a sketch. Okay, so if this is my AB, right? So this is my point A, and this is my point B, and then I have the position of our centroid, right? So we're going to have our variable again. So so our slider, our variable. Okay, so this is our slider. And there's our slider position. Again, it follows the rule that the centroid, the datum starts at the what? At the centroid. Okay, so we're going to analyze this. And again, the analysis starts from where? From Ymax, yes or no? Right? So this over here, based on the transformation that we have, I'm going to draw transformation again. Y, Z, rotation about X, right? So this will be your Y variable. And we know that the distance from here to here, right? We know this distance. Oi. Is equal to 2a. And the distance from here to here is equal to a. Okay. So we're going to find our first moment of area. So QAB is equal to AY bar, right? The area, so the width is T. The depth is 2A minus Y, right? Why 2A minus Y is because this is the analysis direction. Okay, that's our analysis direction. Then you have 2A plus Y times by half, distance of the individual centroid relative to the variable, which is the slider Y. Okay, so over here you have T over 2 bracket 4A squared minus by Y squared. Okay. Then we're going to find the shear stress across AB as a function of Y. Okay. So you have V over IT Now thickness, again, for this case, the thickness is this thickness over here. It's thin wall analysis, right? So this is our T. So the thickness is relative to the what? To the shear